Okay, here I'm gonna talk about how to find the radius of convergence with the or by the ratio test. Okay, here we got two theorems. The first one is that if the limit n goes to infinity of bn plus 1 minus bn exists, then that would be equal to the limit of, as n goes to infinity, of bn over n. And you know, here the limit of bn, the sequence bn as n goes to infinity, is infinity itself. Okay, but you know, this is in the form of this and may exist, may not. Okay, I'm not gonna prove it here. Maybe later I make some video about its proof. Okay, and the second theorem says that if the limit of this exists, oh sorry, not function, if the limit of an plus 1 over an exists, n goes to infinity, then this limit would be equal to the limit of the nth root of an as n goes to infinity. And you know, by that, according to the, you know, the way I talked about to find the radius of convergence, we should have calculated this limit, and according to that we could find the radius of convergence. But you know, if calculating of this limit be hard, you know, this says that you could calculate this, or this limit, the limit of this, like what we did in the ratio test. Okay, now let's prove it. Here's the proof. Okay, and let's define Bn as the ln of an. Ln is just the natural logarithm of an. Okay, now for our series to be exist, you know, I mean, you know, for our series to be convergent, sorry, this, the limit of this should be equal to what? Should be equal to 0. Okay, and you know, in the power series we got something like this, you know, but here I mean an means the whole thing. Okay, not just it's the coefficient of x and x to the power of n. Okay, so this should be approaching to 0, and then here the limit of this as n goes to infinity, an goes to 0, and the limit of this also goes to infinity, minus infinity, or negative infinity. Okay, so let's write this: bn plus 1 minus bn equals to ln, an plus 1 minus ln an, which according to the rules of logarithm equals to ln of an plus 1 over an. Okay, and according to the first theorem, the limit of this would be equal to the limit of this one. Okay, no, sorry, according to this rule, the limit of this, from here the limit of this equals to this. Okay, that's fine, but according to this limit also equals to, I write the equality symbol this way, equals to the limit of bn over n. What was bn? Bn was ln of, here bn was ln of an over n. N goes to infinity. Okay, and this is again according to the rules of logarithm. This here the n goes to the power of an, which means that would be equal to the limit of what is it? This is the ln of the nth root of an. Okay, this is just the rule of logarithm. So everything equal, then this, the limit of this, n goes to infinity, I didn't write it here, would be equal to this. This is equal to this, and this is equal to this. Okay, so these two are equal. Let me since this is ln is continuous, the limit could go inside, which means this limit equals to the ln of the limit of an plus 1 over an, n goes to infinity, equals to, here also the limit goes inside, so that would be ln of the limit of n, the limit n goes to infinity of an, the nth root of an. So we got 2 ln equal, so these two parentheses should be equal, and this is just the second theorem, which means that the limit of an plus 1 over an as n goes to infinity equals to this one. Okay, that's it. I give you some examples in the next videos. Okay.